Okay. Next. Now with this one, I spread these out a little bit more because they're going to need more space. I knew that this number 1, you should know this. This number 2 or 3 in this case, you should know it, but it shouldn't take up much space. And so I did these linearly or across the board, and then these I wanted to keep. These were the harder ones. These are those harder ones. So I want to give these some space. So I would, if I was you, I would just write one at a time, do as much as it needs, and then move on. So with this, we have to remember, this is 27, right? To the 4th power, cube rooted. That they are the same thing.
Wait. Oh, yeah.
Right? Because the bottom is the root. Think of that. Right? What's on the bottom of a plant? The root. Right? So what's on the bottom of the exponent? The root. Does that make sense?
Yeah.
Okay? So I have 27 of these. I'm going to show you a trick I used to use, and I think it works pretty well. And that is, first I break down to 27. Okay? Now honestly, when I used to do this as a kid, I didn't do it like this. I did it like they taught me with the tree method. Right? I know it works. Great. But I don't like it. So I like this now because it's all linear. It goes straight down. So 3, and then that's 9, 3, and that's 3, and 3. And so I know that there's 3 3s in this 27, right? And then the other thing I know is that there's 4 of those. So what this is that there's 1, 2, 3, and then 1, 2, 3, 1, 2, 3, 1, 2, 3. There's 4 of those groups. Does that make sense? Now watch this. I mean, I'm kind of going overboard with this, but I just want to make it very clear. And then this is really a cubed root, so I'm taking out triplets, right? I'm taking out triplets. So every 3 that I circle is a 3 that comes out. Every 3 of them, and they're all 3s, so it sounds weird, but even if they're 2s or 4s, it doesn't matter. Every triplet, I'm going to take out 1 number. For every triplet, I'm going to take out 1 number. For every triplet, I'm going to take out, and there's none left in the box, right? And if there's none left inside the box, then we're no longer cube rooted anymore. The answer is just 3 times 3 times 3 times 3, which is
81.
There you go. Say no more. And that's it. You making more sense?
Yeah.
Okay.
They kind of.
It's weird putting a matrix like that.
Well, because 27, the square of the 3rd root of 27, isn't that just 3?
Yeah.
So you could have just done.
Could have done that and then said 3 to the 4th.
Yeah, can't you?
I wanted to do this because I wanted to show the picture.
Dan, we got 2 minutes left, so do you want to do another one or like?
You want to do all of them? Yeah.
What?
All right, ready?
You want to do those? You want to do those in 2 minutes?
Yeah,
Like
it's
one,
easy.
like a minute and a half?
Ready?
All right.
Okay, so with this one, there's a thing here. What we want to do is cubed root, right? But we are squaring this. So what happens when you square a negative?
Becomes positive.
Yeah. Okay, so right away we know that that's positive, right? And then the other thing is, I'm going to break this down. How many know, and then this is what you were talking about. So I'm going to go a different method with this and just see if you guys can catch on. Go with what you were saying. 2 to the 6th is 64, right? And then you square it, which is how much?
64 times
2, what's 6 times 2?
12.
12. So it's the cube root. So in other words, 2 to the 12 over 3, which is?
2 to the 4th.
2 to the 4th. Which is?
16.
16. And that's a little bit different way of doing it without having to do all this stuff. But you have to understand that what this is in its powers. 2 times 2 times 2. Oh yeah, and you could break it down. 64, and you'll get 6 2s when you break it down. Does that make sense? So it's 2 to the 6th. And then 6 squared, 2 to the 6th squared is just 2 to the 12th. And then that's all cube rooted, right? And so it goes on. Okay, this last one, real quick. Okay, this last one. This is just 16. Or, think of it like this. 2 to the 4th. Hold on. Right, 2 to the 4th. Right? Now, 2 to the 4th to the negative 3 halves. And what that means is, I'm going to have 2 to the 4th on the bottom to the 3 halves. So what that means is, I have the square root of 1 cubed over the square root of 2 to the 4th cubed. Because that's the power, right? This is the square, this is the root. So it's a square root, right, of 4 cubed. What's 4 times 3? 12. So what I'm going to have, what's 1 cubed? 1, right? And then 4, that's 2 to the 12, right? Okay? Oh, and square rooted. Okay, so now, what's the square root of 1? 1. Now remember, instead of writing this square root, couldn't we write that as a half? Right? And what's half of 12? 6. So now we're back to 1 over 2. That's not a 12, sorry. 2 to the 12th. So 2 to the 6th. What is 2 to the 6th? 64. So 1 over 64. And that's number 15. Okay?